Section 2.8, let's look at the floating point data types. A floating point data type would be either of the type float, a double, or long double. Basically, if you are trying to store numbers with the fraction part in it, you would use a floating point data type. You can have a real number like 12.45 or minus 3.8, and it is stored in the form of scientific notation with the exponent of the 10 to show how many decimal places you have. All floating point numbers are signed numbers. Here is again different floating point data type and the number of the bytes that it takes and the range of the number that it shows. For the single precision, if you use the keyword float, you're taking 4 bytes and your number would be ranging between plus or minus 3.4 times 10 to the minus 38 to the plus or minus 3.4 times 10 to the 38, and that's a big large number. Now if you are working with double precision number, you want to use the word double. This one would use 8 bytes and it ranges from plus or minus 1.7 times 10 to the minus 308 to plus or minus 1.7 times 10 to the 3.8. And if you have the long double precision, again you have 8 bytes, and that's your range, which is basically the same as your double. Again, those are large numbers that hopefully you never get to use in your program. If you need larger number than that, then you have to do a little bit creative routine for calculating these numbers in different parts. The floating point literals, they can be presented directly in your statements with the decimal place, or you can put them in the scientific notation. Here's a fixed point decimal notation for the pi or for any number. This one is for E notation for the pi, 3.1415.9 E1. That E1 part says times 10 to the first power, or 10 to the 1. Here is another number, E.25, 6.25 E minus 5, which is the same thing as 0.00000625. Okay, and these are double by default because they are using scientific notation, and they can be forced to be float if you put an F at the end of it, or a long float if you put a capital L. Again, it would be the size of the bytes that you have and the range that you can play for that number. Here's another example that I would like you to try it sometimes. And this program uses the floating point data type. Again, line 7, define the distance to be float. Line 8, the mass to be double. On line 10, it's assigning a scientific notation of a literal to be assigned to the distance. Again, notice it's 1.495979 times 10 to the 11, and the mass is 1.989 times 10 to the 30th. And then when you output those in line 12 and 13, notice how the output is in scientific notation also. This time it brings in and put a plus or minus sign in front of the mantissa part, or the part that is to the power of 10. And the example for the sun is 1.49598 It has a plus 0.11 meters away from us. Okay, and the next statement again for the sun mass, it got 1.989 which is 10 to the plus 0.30 kilograms. This would be the end of section 2.8.